My name is Miroslav Jonas. I'm going to talk about reactive state of mind. So I'm going to try to help you go completely into the reactive world and understand all the aspects. So first of all, how many of you heard about ReactiveX? How many of you know what? Okay, that's pretty much everyone. How many of you are using RX on a daily basis during your working time? Okay, again, quite a lot of people. Okay, let's try something harder. How many of you are using more than 5 different operators on a daily basis? Okay, 3, 4, 5 hands. Okay, let's go even harder. How many of you can tell the difference between these operators? I don't know if you can see it, but it says fork join, combine latest, merge, and with latest from, without looking at animation. Okay, and finally, how many of you think they would be able to explain the whole ReactiveX to someone non-technical, or let's say 8-year-old kid? Difficult, right? Okay, so let's try to understand why is this difficult. When I started working with Angular 2, it was back then alpha version. It was driven completely on RxJS. This was a completely new concept. Although I knew what reactive programming was, the Rx as a library was quite new to me. And I did understand standard event-driven development. So you have something that some event producer and then you subscribe, right? But if you go a bit deeper and you go to RxJS site, you see the definition. First of all, the definition was something like this. It's an API for asynchronous programming with observable streams. For most people, this is like, what? So then if you go further, you see something like this. ReactiveX is library for composing asynchronous and event-based programs by using observable sequences. Again, a couple of phrases that most people don't understand. And finally, our dear Wikipedia says something like this. Reactive programming is a declarative programming paradigm concerned with data streams and the propagation of change. Although all of these definitions say quite a lot, they don't really explain what the reactive is and how the operators work. And if you were unlucky enough to go to RxJS site in the early days, you would see some quite weird definitions of operators that I'm pretty sure even they don't understand what they wanted to say. It was quite hard to comprehend what they are doing. And there was this thing called marbles. Marbles were brilliant for easy operators like map, filter. But when you try to apply marbles to something complex, you suddenly get lost. You don't know where these marbles are coming from, how they are being combined. So one of the things that's now written on the ReactiveX website is this, that it's a combination of best ideas from Observer Pattern, Iterator Pattern, and functional programming. Now, although this is not clearer than the previous definitions, it gives us something to work with. So since I'm a backward man, I'm going to start backwards with functional programming. This doesn't mean that the library or the stuff you're using is functioning. So functional is something completely different. As you are aware, functional programming is core parts of the JavaScript. And there are different definitions. Some of them say that functional programming is the programming where you can use function as a first-class member. In plain English, that means that function can be parameter of another function. You can also combine functions to get some new function or some new object. The most important part for the functional programming is that functional programming tells you that each function has to be pure function. Again, in the plain English, that means that function should not have side effects. There should be 1 or 0 or multiple inputs, and there can be 0 or multiple outputs. But the important thing is that whatever comes in should not be changed inside a function. So the data you pass in the function have to remain the same as they are. And you can pass something new as a result of calculation in your function. But function should not do some side effect. Like if you think about our standard login function, the way we used to do it is that we pass in username and password, then we do some magic, call backend, check if the user is authenticated or not, and then we redirect. This redirection is actually side effect because your function is checking for your credentials. It should not redirect. You should use different flow. And it's part of the way we are used to program and how we are taught to program. So since this was allowed for us, of course we were misusing this in different ways. But once you switch to fully functional programming, it's quite easier to comprehend because then these side effects don't exist anymore. And it's easy to follow the whole workflow of your data. With side effects, you never know what happens. There can be a bunch of different situations you cannot follow. But with functional, you have a clear path. So something comes in, something comes out. It's simple. So the second two patterns are iterator and observable. Most of you, I guess, heard about Django 4. This is referring to 4 authors that created the original 23 design patterns. And iterator and observable were 2 of these patterns. They weren't as used in the beginning, but now with reactive programming, they are becoming more and more popular and more important. So first, iterator pattern. Now, this would maybe have more sense if there was actually pizza today, but unfortunately, you would just have to assume that there is pizza today. And I'm going to try to explain you iterator pattern with a simple pizza example. So you can think of an iterator pattern as a pull mechanism. So let's say we have a pizza, and this pizza is our iterator. The iterator pattern explains that you have a collection of some information, let's call it slices for pizza, and you can take or you can enumerate through these items until you reach the end. So in pizza world, this would mean you can take slices of pizza until there are no more slices left. So pizza provides 2 things. It can give you a slice, and it can tell you, hey, I don't have any slices anymore. So you can come and take 1 slice, and then take next slice, and take next slice. And at some point, the pizza will say, well, that's it from me. Clear enough? OK, let's go to observer pattern. Observer pattern is your gramma. So let's see how we can explain observer with a gramma. So in contrast to pizza and the pull, gramma is working more on a push mechanism. So what happens, you go to your gramma and you say, hey, gramma, I'm hungry. And gramma starts creating pancakes. And you sit in the table, and the first pancake arrives. And then the second. You don't have to ask for pancakes, they just keep arriving. And also, on top of it, you can do some operators on top of the pancakes. So let's assume the substance from which the pancakes are done is one type of observable. And then you have heat as a second observable. And then you can combine the pan with the substance and the heat to get a pancake. And then normally, gramma doesn't make 1 pancake at a time and deliver it 1 at a time. She creates some sort of buffer of pancakes. And then when she has 10 pancakes, she brings it to you. And then you can use your map function or scan to enhance the pancake with jam, and then map to wrap it into pancake and then eat it. So you can explain pretty much the whole process of making and eating pancakes through the observable. The important thing is that it works with a push, so you just have to initiate the stream or tell grandma that you're hungry, and she starts making the pancakes. Now, there are 2 types of observables, which you might have heard. One of them are cold, and the other one are called hot observables. Since I like sushi a lot, I'm going to try to explain this on a sushi principle. So let's say you want to eat sushi. So in Vienna, pretty much there are 2 ways how you can do it. You can go to a standard restaurant, you can sit there, You order a sushi, then there's some async wait time, and after some time, your sushi arrives. Now, the difference between observables and promises, which is one of the core differences, is that observables are cancelable. So with promise, if your sushi was a promise, that would mean that once you order, you are chained to the table and you cannot leave before you eat it and you pay for it. But with observable, you can order sushi and you can change your mind and say to waiter, hey, actually I want something else. Or you can just bail, just leave, and who cares? The second kind of way how you can order sushi is go to running sushi. Is anyone familiar with running sushi? Okay, most of you. So for those that are not, it's the place where you have sushi as all you can eat. So you just sit, and then sushi is circulating around you, and you just take whatever you want. So you can sit there as long as you want, and you can take as much as you want sushi. So for this sushi, you don't trigger the event stream. It just keeps going. Whether you're in the restaurant or not, the sushi is there and it's going in around. Whether you take it or not, it's up to you, but the sushi keeps running around. And this is how the hot observables work. So in IT world, this would be, for example, mouse clicks or mouse moves or keyboard clicks or whatever type of stream that keeps going, or like listening to the radio. So you can switch on your set and listen to the radio, but if you don't, the radio will still be there. The broadcast is still there. It's not just for you, it's there for everyone. So now I'm gonna show you how to build a relatively complex game in an iterative world, but in a relatively simple way with Rx. So, as you can see, is the game of Tetris. I guess most of you are familiar with this game. So it's an old Russian game that used to be quite popular in 90s because everyone had these small gadgets where they were playing Tetris with. But it was one of the first oral popular games created on computers. So I did some work up front. I was cheating, I have to promise. So I created something like shapes, which is the definitions. I don't know if you can see it. Maybe I can reduce it as well. Still visible? So we have like definition for point, definition for shape. So shape has 2 dimensions. It's some sort of matrix. It has a block. We have a random index generator. We have our predefined shapes, etc. Also, there are some constants which we're going to use, like the colors, the keys we want to deal with. So we're interested only with arrow left, arrow right, down key, and space, which will be our rotation. We have some definitions here, our game speed, and that's pretty much it. Also, there are, of course, the core part, which is the different methods that are modifying the scene or checking if the game is over, generating the blocks, moving, rotating, etc. But we're going to go back to our game. So at the moment, as you can see, there's pretty much nothing in the game. We have just reference to canvas. It runs this method, which again doesn't have anything. So let's try to analyze what one Tetris might need. So first of all, I said that we defined some keys. So let's see what we can do with those keys. So we're going to define one observable, and we're going to call it from event. And let's take it here. So we say document, and then we're going to say key down. And let's just call subscribe on it. Okay. And now when we run this, let's just bring this console log. And now let's try to click OK. So we have our keyboard events. OK, but we are not interested in this whole object of keyboard event, right? We are probably interested just in a code. So what we can say that pipe. Now, for those who are unfamiliar with pipe, I'm going to come back to that later. But for the time being, let's just say that all the operators with a pipeable or lettable operators are now organized under pipe. So it's easier to kind of comprehend what's going on. So you have clear observable, you have subscription, and you have your methods in between. So let's say we want to take event, and we're interested in event.code. And let's see what happens now. Okay, there. Now, as I mentioned, we have 4 keys that we're interested in. So we don't really want to listen to all of them, and we're going to map them to this object. It should be keys. Now, if I start clicking, you see that sometimes it comes as undefined. That means that some of the events that we are triggering are not being mapped. So we want to get rid of this, right? So we're going to go filter, and again, filter, we want from operators, and we're going to say key, return me just the keys that have value. Okay. Now you can't really see, but I'm like randomly typing on a keyboard, and nothing happens unless I hit one of the keys we're interested in. So what do we have next? As a game, we want the game to have some sort of natural progression. Like even if you don't type on your keyboard, these blocks will still be moving. And we have to make them somehow move, right? So first we want to create interval. So this will be our main mechanism, and we want to say that it will run on game speed, which was 500 milliseconds. And again, we want to create subscribe. So we have some number, and we want to console log it. Okay, now you can see it's generating something, but it's not the numbers we want, right? We want key down event, because what game should eventually do, it should move this block one line at a time. So we can, again, use pipe first, and then we're going to map. We don't care about the number. So we return just keys.arrow down. So now if I run this, you can see that the arrow down function has been triggered. Now, if you look at these two subscribes, they are pretty much the same, right? So let's create something that would combine them together. So we're going to create one action subject. Now, for those of you that don't know what subject is an object in observable world that's both observer and observable. So you can subscribe to it as to any observable, but it can also subscribe to something. So let's pass this to actions. So now instead of sending it to console log, we're going to send it to actions. And then we can do something like this. Random L. Okay, so when you look at the console log, it's still the same, right? So it's still reacting. Okay, now what we need to do next is on every key, we need to generate our scene. Our scene will consist of the board and also the object. I can hide this now. So let's write something like this. Actions. And then we're going to write pipe. Now what we want to do is we want to bring the scan function. Now scan function is similar to the reducer, to reduce in array, with the difference that standard reduce only creates a response at the end. So let's say you have a array of numbers. So if you create a function that sums it up, the reduce on this array will just give you the final number, the final result. Now scan does this, but it also sends the current sum in every step. So if you have numbers from 1 to 5, it will send 5, then 3, then 6, etc., until it reaches the end. So on every action, we're going to call the method called modify scene, which I'm going to show in a second. And as our first step, or as our initial step, we're going to call generate scene. Now, if I go here, you can see the generate scene doesn't do much. It just takes port shape and generates the block. And generate block is just taking a random shape, setting a random color, and setting the initial starting point. So, yeah, one more thing. So this is the modify scene. It reacts on arrow down, for example, and it tries to move it. If there was a move, then it, if the move cannot be done anymore, then it adds the block to the board. It detects if there is some row that is completely full, that you can remove it. Again, on arrow left, it's just moving left or moving right, and on space, it's rotating. So not much to it. Now, this is this action will now return the following. Subscribe. Will return the following result. So let's see what we have here. Okay, so we are getting some object, and you see there's a board and there's a block inside. So instead of returning just this object, let's try to render it. So we can call something like this. We can say that on next, next we have our scene, and we're gonna do render scene by passing the context and scene. Let's see what this brings us. Okay, nice, right? Now bear with me, we are not done yet, so. Okay, now if I would just pull this down quickly, it's not as fast as it could. See, nothing happens, they just keep falling. So we have to solve this, right? Okay, let's call this our scene and get rid of this. Okay, so we don't want to run this endlessly, right? Ideally, we would like this to stop at some point. So we're going to again use our pipe. And let's say take while. Oh, scene. So this method just checks if our game is over. Now, if we just bring them down quickly. Again, this is not showing anything, so we're doing something wrong, right? So let's see what we might be doing wrong. When we are running the subscribe, we are rendering the scene on next. But although our observable has ended, because the take while happened, we don't really see it, right? So let's check if we can render it. So on complete, we're gonna say render game over. And we're passing just the context. Let's see if this changes something. So again, quickly down. Oh, there it is. Now, I don't know if you can see it, but there's some jumpy animations happening there whenever I move things. So it's not as fluent as we would like to be. So let's see what we can do. Now, sorry. So we're going to just leave it as it is. One thing that we want to do, we don't want to render the scene every time. We want to render a scene, say, 60 frames per second. So we're going to create one interval. And we're going to pass it FPS. That's my constant, 60 frames per second. So that's just 1,000 divided by FPS. And on top of it, what we want to do is we want to reserve our animation frame. So we're going to use animation frame for Rx. What this does is pretty much makes sure that you have your animation frame request, that whenever you want to render, your CPU is free to do it. So there's nothing else running in the background. Now the interval, as we know, returns just a number. So we need to map this to our scene. So we can use something like with latest from. And now we have our scene observable, and we have our method. So the first parameter is a number from interval. We don't really care about that. And the second is scene. And we're going to return just scene. So what this does, this every time when the interval fires, which is hopefully 60 times per second, it will take the latest value from our scene, and it will send this instead. And again, then, okay, that's better. And then we can continue working with scene. So that's pretty much, we switched from our integer or our number to the current scene. We are checking if scene is not game over. We subscribe and render. So let's see now. Animations are, by the way, you can rotate them, of course. Let's see if we can get rid of this line. Okay, there's one more thing which we shouldn't forget, and that's getting rid of the observables once we are done. So as you know, observables are just the event streams, and once you start listening to these event streams, your listeners remain there. So what we want to do, we want to make sure that we get rid of these event streams when the application is done. So some of them, like this scene, they don't really happen on their own, but stuff like interval, it's pretty much generating on its own. Key down event as well, interval. So what we're going to do here is we're going to create one subject, which we're going to call destroy. And we're going to make sure that on destroy, maybe you've seen this all, this is pretty good practice. We're going to call next, which will fire value, and then we can call this destroy.complete, because we don't need it anymore. Now what we want to do is we want to make sure that all of these are done. So what we can do is we can say take until, and then pass our destroy. And we can do this for interval as well. This is really good practice because then you have it in one central place. And you know that ng on destroy will be called every time you close your component or destroy your component. And on the other hand, this destroy will make sure that everything gets destroyed. So here again, take until this dot. So now when you look at this couple of lines of code, this is pretty much the whole game, the whole application. There are, of course, these helper methods that calculate everything, but the main flow is explained in these few lines. Now just try to imagine how you would solve this without observables. So for key event, you would have some add event listener, then you would have to make sure that you know at which point you have to detach from this event listener. With intervals, again, you would have to make sure that the interval is not running, and you have to combine, and combination of this would be horrible. You would have to keep some state, and yeah, creating this whole in iterator world would be just huge mess, and most likely you would miss something, you would get some memory leaks. With Rx, the take until makes sure that there are no memory leaks. So once you're done, everything gets cleaned up. Also, the important part is that Rx is by default pure function, so it doesn't mutate your object. Whatever observable comes in, something completely different comes out. So it makes sure that it doesn't change the original observable. If you create observable and then you map it to something else, you can still subscribe to the first observable and you would still get the original data, although it was mapped to something else. You can have two separate instances. And this is really powerful because by using the event streams, you can organize your entire application. So you just have to think from user perspective. What do I want to do? What is the user flow? Does the user clicks here, or does he does this? And then what happens on this click, or what happens on this input field? So once you are able to visualize these streams, then everything else is simple. Then it's just a matter of picking the right operators, picking the right observables, and linking them together. And the important thing is that when you have some error or something is wrong in the application, you can simply just follow the observable stream and figure out what happened. With iterables, it's quite difficult because something somewhere might go wrong. If you're using promises, at some point something breaks, and if everything is changed, you really don't know what happened. With observables, you can easily follow. So let's get back to the presentation. I promised that I will talk about pipeable or lettable operators. So in the beginning, they were called lettable because they were similar to existing let operator in Rx, but they decided to call it pipeable because it makes more sense, and as you can see, it uses pipe to link the operators together. So why were they introduced at all? It came with a version 5. It's pretty much standard in a version 5.5, and this is how we started, and at least I started this way. So there was this Rx library. I just took everything in, because why would I import piece by piece? Let's just take everything, right? And then you bundle your application, and suddenly it has 7 megabytes, because Rx is huge. There are like hundreds of operators. And some of them depend on stuff that's not even Rx, so it bundles again with a bunch of node modules which you don't really need. So there came the prototype patching. That was a nice way to separate the functionality. So you would take just the core observable, and then you would import operators. So by doing this, you are actually patching the observable. So observable itself didn't have anything, and then you import this line, and under the hood, it adds the Ajax method to the observable. Then this one adds catch, and this one adds map. This was nice because the size was reduced, but the bad thing was that it's quite easy to forget this, and we still have it this way in our application, and we just had the issue today with this, that we just forgot one operator. And it's quite easy to do this because there's no intelligence, there's no UI helping you, telling you, hey, you're missing this. So there was then another way. This is pretty much supported by Angular team. And if you look at their code, especially the router, which is completely built on top of Rx, you can see that this is how they're calling it. So by importing it directly per operators, they make sure that every operator is there and that nothing is missing. The bad thing is that JavaScript call function by default doesn't have type. So response is any. So all these intelligence and nice things that that TypeScript brings is completely gone. And this is especially hard if you are trying to figure out what's going on in Rx. If you ever try to debug router, you will just end up in hundreds of observables calling each other, and your original code is completely gone. You can't even see from where you call this. You just get lost in the observables. And this was, of course, pain for debugging. So that's pretty much the main reason why ReactiveX team decided to bring pipes. With pipes, you have the same benefit of the call, where you can pretty much target directly the parts that you need. And instead of bringing observables and then patching it, you're actually bringing the different types of observables. So if I would like interval, I just bring interval, which is completely isolated part. It's built on top of observable, but it's completely separate. And then I can use pipes to nicely organize my operators. And the best thing is that if you try to debug, you can actually see the whole flow. You can track it. So it's no longer a mess of different observables. You can nicely follow what's going on. So that's it, and hopefully you can see this nice video. So once you learn the secrets of Rx and learn how the operators work, then doing synchronizations like this won't be a big deal for you. If you're interested in the game itself, it's hosted on a GitHub. These slides will be available probably tomorrow already on the meetup page. That's my handle for Twitter if you want to follow me or just want to see what's going on. Thank you for your listening and hope it was worth it.